Imagine a world without metals, glass, fuel and construction materials. There would be no buildings, transport, roads, industries, machines or appliances. Metals and fuels have made our social, industrial and economic development possible. All these materials come from substances called minerals, found embedded in rocks in the Earth's crust. Minerals are defined as naturally occurring homogeneous substances that have a definite internal structure. Some minerals are essential for our body to carry out its chemical and biological processes. These minerals are required in very small quantities, but are essential for the proper functioning of the organs in our body. You will be surprised to know how many different minerals you use in everyday activities. For example, brushing your teeth. The toothpaste you use contains limestone, aluminium oxide, silica and phosphate minerals for cleaning, titanium oxide for its white color, fluoride to prevent cavities, and mica for sparkle. Other examples of minerals utilized in articles of daily use are tungsten in ballpoint tips and filaments in light bulbs, nickel in rechargeable batteries, silver and argentite in photographic films, and graphite in pencils. Remember that rocks themselves are not minerals. Rocks contain minerals mixed with organic material. Here is a rock that contains the greenish mineral called cuprite, which is used to extract copper. If you pick up a piece of rock, chances are that it contains several different types of minerals. However, some rocks, like blocks of limestone, are made entirely of a single mineral called calcium carbonate. Minerals are of interest to both geographers and geologists. While a geographer is concerned about the distribution and economic importance of a mineral, a geologist is more interested in the formation, age and composition of minerals. Geologists classify minerals based on their properties. However, the properties of a mineral depend on the elements it is made of and the chemical and physical conditions in which it was formed. Here are 3 minerals made of carbon. Observe how they differ widely in their hardness, crystals, luster and density due to the difference in their conditions of formation. For commercial purposes, we can classify minerals as metallic minerals, non-metallic minerals, and energy or fuel minerals. The metallic minerals can be further classified as ferrous minerals, or the ones that contain iron, non-ferrous minerals, and precious metals like gold, silver, and platinum. If we start looking for minerals in the Earth's crust, we will find them in some very interesting formations. Let us take a look at some modes of occurrence of minerals. It is interesting to know that aluminium is found in around 150 known minerals. But only one of them, bauxite, is majorly used to extract aluminium. Abundantly available minerals that offer sufficient concentration of an element and a commercially viable process of extraction are called ores of that element. Thus, bauxite is an ore of aluminium. If we go digging in igneous or metamorphic rocks, we will find minerals as minor deposits, called veins, or bulky thick deposits, called lodes. These veins and lodes form when molten minerals are pushed up into crevices between rocks. Most metallic minerals like copper, zinc, lead, and tin are found in such formations. If we look in sedimentary rocks, we will find minerals like coal and iron ore in thick beds or layers. These mineral beds are formed due to great amounts of heat and pressure exerted on mineral deposits over millions of years. We also come across vast beds or layers of minerals like gypsum, potash, and sodium salts. These beds are created when mineral-rich water evaporates, leaving the minerals behind. We may not always have to dig very deep into the Earth's crust to find minerals. Some metallic minerals, like gold, silver, platinum, and tin, are found as alluvial deposits in the sand and soil in valleys. Such alluvial deposits are also called placer deposits. We are also saved the hassle of digging into the earth when mineral-rich rock gets weathered and decomposed by natural agents. This leaves behind the residual mass of weathered material that contains a high concentration of minerals. Bauxite, an aluminium-rich mineral, is usually found as such deposits. As you know, around 70% of the surface of the earth is covered by water. The water of the seas and oceans and the ocean floors also have rich mineral deposits. Ocean waters are a rich source of minerals like common salt, bromine, and magnesium, while the ocean floors are loaded with mineral deposits like manganese nodules. Minerals are natural resources and their distribution in the Earth's crust is not uniform. India has rich mineral resources in some parts of its territory. The peninsular region with parts of Rajasthan, Jharkhand and Orissa supplies most of our metallic and non-metallic minerals and coal. The coastal regions and parts of Assam and Gujarat have most of our petroleum deposits. The places from where mineral ores are extracted are called mines. Mining is done through large excavations on the surface, as in open pit mines or underground by digging a vertical shaft in the hard rock and forming tunnels along the shaft by excavating material. All the mineral reserves in India are owned by the government. However, in the tribal areas of northeast India, individual persons or communities lay claim to mineral resources. In Meghalaya, families lay claim to coal deposits and mine coal by digging long narrow tunnels in the ground. This practice is called rat hole mining. You already know that ferrous and non-ferrous minerals are two types of metallic minerals. While ferrous minerals contain iron, non-ferrous minerals do not contain iron. Ferrous minerals constitute about 75% of the total production of minerals in India. The production is so large that India exports substantial amounts of ferrous minerals after meeting the domestic demand. Iron ore and manganese are two important ferrous minerals mined in India. From the spoon on your table to an artificial satellite orbiting the Earth in space, most of our industrial and scientific developments are made possible by a mineral called iron ore. Iron ore is a source of iron and steel and occurs in many forms. India has rich reserves of several good quality iron ores. The two main ores of iron are magnetite and hematite. Magnetite has higher iron content than hematite. Karnataka and Orissa are the main iron ore producing states in India, followed by Chhattisgarh and Jharkhand. If you map the location of major iron ore mines in India, you will see that they fall in 4 distinct regions. These regions, called major iron ore producing belts of India, are the Orissa-Jharkhand belt, the Durg, Bastar, Chandrapur belt, the Bellary-Chitradurga, Chikmagalur, Tumkur belt, and the Maharashtra-Goa belt. High-grade hematite is mined in the Badam Pahad mines in Mayurbhanj and Kindur-Jhar districts of Orissa. Hematite is also mined in Goa and Naumundi in Singhbhum district of Jharkhand. The Durg-Bastar-Chandrapur belt is spread over parts of Chhattisgarh and Maharashtra. You will find the famous Baila Dila hills that look like the hump of an ox. These hills contain 14 deposits of hematite that is ideal for making steel. The produce from these mines is exported to Japan and South Korea via Visakhapatnam port. The Bellary, Chitradurga, Chikmagalur, Tumkur belt lies in Karnataka. The Kudremukh mines in this region hold one of the largest deposits of iron ore in the world. Something very interesting happens here. The entire iron ore mined from Kudremukh is mixed with water to make slurry that is piped to a port near Mangalore for export. The Maharashtra-Goa belt is spread over parts of Goa and Ratnagiri district of Maharashtra. The iron ore found here is not of very high grade. Yet, a substantial quantity is mined each year. Iron ore from the Maharashtra-Goa belt is exported through Marmagaon port. Industrial iron and steel are both produced from iron ore. The advantage that steel offers over iron is its non-rusting property. Steel is a mixture of several minerals besides iron ore, and one such important mineral is manganese. Besides being used in making steel, manganese is mixed with other metals to make alloys to produce food and drink cans. Manganese is also used in the manufacture of batteries, paints, and industrial chemicals like bleaching powder and insecticides. Orissa is the main manganese producing state in India, followed by Madhya Pradesh and Karnataka. Let us now move on to non-ferrous minerals. The reserves of non-ferrous minerals in India are not as abundant as those of ferrous minerals. Copper and bauxite are two important non-ferrous minerals mined in India. Being highly malleable, ductile, and excellent conductor of heat and electricity, copper finds many applications. Copper is widely used in the electrical, electronic, and chemical industries. Madhya Pradesh, Rajasthan, and Jharkhand are the main copper-producing states in India. The Balaghat mines in Madhya Pradesh, K3 mines in Rajasthan, and Singhbhum district of Jharkhand are the leading producer of copper. Our copper reserves, however, are not sufficient to meet our needs. Aluminium is a strong, yet lightweight metal derived from a non-ferrous mineral. If you look into your school bag, chances are you will find some aluminium there. It may be in the form of your geometry box, your lunch box, or the shiny foil in which your chapatis are rolled. Aluminium also finds use in making vehicles, paints, wires and cables, doors and windows, and much more. Bauxite is the main ore of aluminium. Bauxite deposits are left behind by the weathering of rocks rich in aluminium silicates. Orissa is the main bauxite producing state in India, accounting for 34.97% of the country's total production, followed by Gujarat, Jharkhand and Maharashtra. The Amarkantak Plateau, the Mekal Hills, Bilaspur, Kathni and Panchpatmali in Koraput are the main regions where bauxite deposits are found in India. Did you know aluminium was so highly prized after its discovery that Napoleon Bonaparte wore buttons and hooks made from aluminium on his clothes? Aluminium vessels were used to serve food to the most important guests, while the others ate in gold or silver utensils. However, within 30 years, beggars on the streets of Paris were using aluminium bowls to collect alms. Besides metallic and energy minerals, there are a number of important minerals classified as non-metallic minerals. In this module, you will learn about two such non-metallic minerals, mica and limestone. Mica is a non-metallic mineral composed of thin leaves joined together that easily separate into individual sheets. You can find mica in many colors, from transparent to black, green, yellow, brown, and red. What makes mica special is its property to provide excellent electrical insulation with low power loss, even at very high voltages. Mica is used extensively in the electrical and electronics industries to make insulating materials, heating elements like the one found in your electric iron, and capacitors used in electronic circuits. The main mica producing regions in India are the northern Chota Nagpur Plateau in Jharkhand, Ajmer in Rajasthan, and Nellore in Andhra Pradesh. The Koderma, Gaya, and Hazaribagh belt in Jharkhand is the largest producer of mica in India. Another important non-metallic mineral mined in India is limestone. Limestone is a form of sedimentary rock almost entirely composed of calcium carbonate. In some instances, magnesium carbonate is also found in limestone rocks. Limestone is mainly used in smelting iron ore in the blast furnace for producing raw iron. Limestone is also an important ingredient in the manufacture of cement. Andhra Pradesh is the main limestone producing state in India, followed by Karnataka and others. From our discussions so far, you would know that mining is an important economic activity. However, it comes with its own hazards. Mine workers face serious risks to their health and life. Landslides, fire, and underground flooding cause many casualties every year. Miners also face the threat of serious lung and heart diseases due to the toxic fumes and vapors inhaled during mining. Besides affecting the health of miners, indiscriminate mining leads to extensive deforestation, resulting in ecological disasters. Dumping of mining waste results in soil and land degradation, and pollution of air, and freshwater bodies. We need stricter laws and implementation of personal and environmental safety regulations to keep mining a safe activity. No matter how much we improve the conditions of mines and mine workers, mining activity cannot go on forever. This is because usable minerals that form the basis of our industrial and agricultural growth are only about 1% of the Earth's crust. The formation of minerals is a very slow process. Minerals available to us today were formed over millions of years. Thus, minerals are limited and non-renewable resources. As we dig deeper and deeper into the earth to extract more and more minerals, we get poor quality ores at much higher cost. Eventually, continuous mining will one day completely exhaust our mineral resources. There is an immediate need for planning and technological solutions to conserve our mineral resources. Recycling and reusing material like scrap metal and reducing the use of minerals by finding suitable substitutes can help us conserve our mineral resources. We need energy in different forms for all our daily activities. We derive energy from several resources. Some of these resources have been in use for a long time and are called conventional sources of energy. Some other resources, called non-conventional sources, are relatively new sources of energy. The conventional sources of energy include firewood, cattle dung cakes, minerals like coal, petroleum, and natural gas, and electricity generated by flowing water or burning fuel. The non-conventional sources of energy include solar energy, wind energy, tidal energy, geothermal energy, atomic energy, and biogas. In this module, we will discuss some of the conventional sources of energy. In most parts of rural India, firewood and cattle dung cakes are the primary sources of energy, meeting around 70% of the total energy requirement in our villages. The use of firewood is being discouraged to preserve our shrinking forests. The use of cattle dung cakes is also on a decline, as cattle dung can be converted into more valuable manure, which is an excellent natural fertilizer. Coal is another important conventional source of energy. When you hold a piece of coal, you are actually holding a part of a tree that grew on the earth millions of years ago. Over the years, the intense heat and pressure turned this prehistoric plant material buried under the earth into coal. Coal found in different regions may look very different and have different properties. The variety of coal depends on how long the plant material had been buried, at what depth and under how much pressure. Peat is a type of coal produced in swampy areas due to the decay of plants. Peat is a low-carbon variety that has high moisture and provides low heat output. Lignite is a soft, low-grade variety of coal that has high moisture content and appears brownish in color. Lignite is mainly found in Neyveli in Tamil Nadu, where it is used to produce electricity. Bituminous coal is formed from plant material buried deep in the earth and subjected to very high temperature. Bituminous coal is the most important commercial variety of coal. High-quality bituminous coal is used in metallurgical applications like smelting of iron. The best and the most expensive variety of coal is called anthracite. Coal is the most abundant fuel mineral found in India. We are heavily dependent on our coal reserves to meet our energy needs. Besides being used directly as a fuel, coal is used to generate thermal electricity that is used to meet a large part of our domestic and industrial requirements. Coal is found in rocks belonging to different geological periods. In India, coal is found as Gondwana deposits that are over 200 million years old, and tertiary deposits that are just about 55 million years old. The Gondwana deposits in India are found in the Damodar Valley in West Bengal and Jharkhand. Jharia, Raniganj and Bokaro are important coal fields in this area. Gondwana deposits are also found in the Mahanadi, Godavari, Son and Wardha valleys. Tertiary deposits of coal are found in the northeastern states of Assam, Meghalaya, Arunachal Pradesh and Nagaland. You will note an interesting pattern if you compare the position of coal fields with major thermal power plants in India. Since coal is bulky and expensive to transport in large quantities, most power plants and heavy industries relying on coal are located near coal fields. After coal, petroleum is the most important fuel mineral found in India. Besides providing fuels like petrol and diesel and industrial lubricants, petroleum also provides raw material for a number of industries, including textiles, fertilizers and cosmetics. The different variety of products that spawn from petroleum makes petroleum refineries a nodal industry. Petroleum deposits are found in anticlines and fault traps in rock formations. This happens when an oil-bearing porous limestone or a sandstone layer is trapped between layers of non-porous rocks that prevent the rising, sinking and further migration of oil. Offshore oil fields in Mumbai High account for 63% of the total petroleum production in India. This is followed by 18% of the production coming from Gujarat and 16% from Assam. Besides Mumbai High, Ankleshwar in Gujarat and Digboy, Nahar Katia and Moran Hugrijan in Assam are other major oil fields in India. Assam also has the distinction of being the oldest oil-producing state in India. Natural gas is a mixture of gases, primarily methane, which is found trapped in rocks. Natural gas is a clean energy fuel due to its low carbon dioxide emission. It is being promoted as the new generation auto fuel as compressed natural gas or CNG. You might have seen CNG filling stations in your city. Natural gas is used in the fertilizer industry and also used to generate electricity. In India, large deposits of natural gas have been found in the Krishna-Godavari basin, Mumbai High and the Gulf of Cambay. The Andaman and Nicobar Islands also hold important reserves of natural gas. Power plants and fertilizer plants are the main consumers of natural gas. Thus, the natural gas fields in Mumbai High and Bassein are linked to the power and fertilizer plants in western and northern India by the 1,700 km long Hazira Vijaypur Jagdishpur or HVJ natural gas pipeline. The form of energy that is used the most extensively in our homes and industries is electricity. The per capita use of electricity in our country is considered an indicator of its development. It is interesting to note that the electricity that runs our industries or lights up our homes could be derived from a fast-flowing river. Fossil fuels like coal, petroleum and natural gas, or tiny invisible atoms. The electricity generated by the energy of flowing water is called hydroelectricity. Flowing water is a renewable resource. Thus, hydroelectricity is produced using a renewable resource of energy. The map here shows some major hydropower plants in India. Large hydropower plants like Bakranangal, Damodar Valley Corporation and Kopili are called multi-purpose river projects. Electricity generated from the heat of burning fuel minerals like coal, petroleum and natural gas is called thermal electricity. Note that thermal electricity is produced using non-renewable fossil fuels. India has over 310 thermal power plants. The map here shows some major thermal power plants in India. A large amount of heat energy is released when the atomic structure of radioactive elements, like uranium, changes. This nuclear or atomic energy is also used to generate electricity. At present, India has 6 operational nuclear power plants in Uttar Pradesh, Maharashtra, Karnataka, Rajasthan, Tamil Nadu and Gujarat. The uranium and thorium used to run these nuclear power plants is sourced from Jharkhand and the Aravalli ranges in Rajasthan. The monazite sand of Kerala is also rich in thorium. Growing urbanization and industrialization in India is creating more and more demand for energy. At present, we largely depend on fossil fuels for our energy requirements. However, their increasing prices, shortage in supply, and environmental concerns against their use can severely affect our energy security. The answer to the problem of energy security lies in using non-conventional sources of energy like solar energy, wind energy, biogas, tidal energy, and geothermal energy. Being a tropical country, large parts of India receive bright sunshine during most parts of the year. This makes solar power a huge potential source of energy in India. The secret of using solar power lies in photovoltaic technology. This technology uses panels made of photovoltaic cells that trap solar energy and convert it into electricity. A milk can sterilization facility in Madhapur near Bhuj has the largest solar power installation in India. The use of solar energy in lighting and cooking in rural India can reduce the dependence of villagers on firewood and cattle dung cakes. This will automatically lead to conservation of the environment and more supply of organic manure. The large fans you see in this picture do not run on electricity. They are actually wind turbines that produce electricity using the energy of the blowing wind. A number of such wind turbines are set up together to form a wind farm. The map here shows the main areas where wind energy is being harnessed in India. The largest wind farm in India is in Tamil Nadu, spread from Nagarcoil to Madurai. You will also find wind farms in Andhra Pradesh, Gujarat, Maharashtra, Karnataka, Kerala, Lakshadweep, and Jaisalmer in Rajasthan. You must have seen cattle dung cakes being used as fuel in villages. This waste can be put to better use. Animal, human, and farm waste produce biogas on decomposition, which is a better fuel than kerosene, cattle dung cakes, firewood, and coal. Biogas plants that operate on animal waste are called gobar gas plants in India. They not only provide an efficient alternative source of energy and better manure for fields, but also conserve our forest by reducing the demand for firewood. If you live near the sea, you must have seen the daily tides coming in and going out. These tides are used to generate electricity. On high tide, the water is allowed to flow in a storage area, and on low tide, the water is allowed to flow back. In both cases, the flowing water is used to produce electricity. The National Hydropower Corporation has set up a 900 megawatt tidal energy plant in the Gulf of Kutch that provides excellent conditions for harnessing tidal energy. If you start digging a hole towards the center of the earth, you will find that it gets hotter and hotter as the depth below the Earth's surface increases. This heat trapped in the depths of the Earth is called geothermal energy. Groundwater absorbs geothermal energy and, at some places, shoots out as geysers of hot water and steam. This steam is used to generate electricity. Hot springs have been discovered in many places in India. Experimental projects to utilize geothermal energy have been set up at the Parvati Valley near Manikaran in Himachal Pradesh and the Puga Valley in Ladakh. The most important requirement for all the growth in agriculture, industries, trade, and transportation is energy. Energy is also what makes our modern lifestyle possible. After independence, India has embarked on an ambitious path of economic development by expanding agriculture, urbanization, and rapid industrialization. All this development is increasing the requirement of energy in all parts of the country. Now, let us take a look at our primary resources of energy. We are largely dependent on fuel minerals like coal, petroleum, and natural gas to fulfill our energy requirements. A large amount of electricity is also generated by burning fuel minerals. Minerals, as you know, are non-renewable resources. This means that the supply of coal, petroleum, and natural gas is limited. Thus, heavy dependence on fuel minerals for energy is not a sustainable plan to meet our future energy requirements. A sustainable path of energy development involves a two-fold approach. On the one hand, it involves finding renewable, non-conventional sources of energy. And, on the other hand, it involves conservation of the energy available today. Thus, our future energy security lies in developing and using renewable, non-conventional sources of energy like solar energy, wind energy, biogas, tidal energy, and geothermal energy. A lot of energy is wasted in our country through inefficient means of usage. Conservation and judicious use of our energy resources is essential to improve the energy situation in our country. We can conserve fuel minerals like petroleum and natural gas by forming carpools and using public transport instead of private vehicles. We can also conserve scarce fuel minerals by using better, renewable fuels like biogas in place of coal for cooking. Conservation of energy is as important as conservation of energy resources. You can contribute to energy conservation by switching off all lights, fans, and electrical devices when not required. These days, a number of power-saving devices are available in the market for your electrical and electronic appliances. These devices not only reduce wastage of power and help conserve electricity, but also reduce your monthly electricity bill. We are all responsible for ensuring energy security for the future. And conserving energy is one way to do so. Remember, energy saved is energy produced.